as a French writer was saying, the future is not what it used to be. And I think the best way to speak about the future is to start thinking back a little bit of the past. As you pointed out that Europe has been strongly involved in the creation of the current generations of wireless technology, and as I remember, around mid-2006 there was discussion ongoing on the principles of long-term evolution, which ultimately became 4G. So people were discussing the evolved packet core, and other people were discussing what radio interface would we need, and they decided to go for OFDM. And by the way, OFDM was invented by Orange, France Telecom at that time, demonstrated in 1988 in a live DAB broadcast, and that has been done also in the framework of a European initiative. So we have strong history. But in mid-2006, what happened? June 2006 was the time Apple went out with the first iPhone. And the first iPhone was Edge. It was 2G, but it was the first smartphone. And think about what happened in the usage and the way software and apps have been developed and bubbling and exploding on the top of the excellent wireless technology that we were designing in this period of time. The engineers at Apple, the software guys at Apple were creating another revolution, which was the smartphone industry and the next 7 years. So that was just 7 years ago. Okay, so 7 years in the future, we have to think: is there going to be a revolution? Is there going to be something different? And my key message today is that yes, 4G is a very good technology. We are deploying 4G, and actually Orange is deploying 4G faster than ever any other technology. Now, much faster in coverage, much faster in penetration, faster than 3G, faster than 2G. So it's an excellent technology. It's capable of evolving, but it has been designed between 10 and 7 years ago. The requirement, the thinking was before we created the revolution of the smartphones. So 5G must not be thought as just another generation, more bit per second, more speed. This is going to happen, and 4G can evolve and get more bit per second and more spectral efficiency and more capacity. We have room for improvement in this solid technology. So we have to think of 5G as what's going to be different. And Mario referred to ambient, and let's think 5 seconds about the air you are breathing. We're not thinking often on the air we breathe. And the air is important. Of course, if you go in the mountains, you have a little bit less air. Sometimes it gets smelly, but no, you live because you have air. Okay? In this horizon of 2020, we have to think of wireless internet, the mobile internet, the fixed mobile converged global infrastructure, exactly as air. We will have so many applications, so many new things that we don't know now. 7 years is a long time frame in terms of rate of evolution, the Moore law, the software, accelerated creativity and innovation. So we need something as good as air, as important as air. If I continue the metaphor, air is not only for human. We are populating air with our sound and using air to transmit, but animals are using air, plants are using and generating air. So in the 5G horizon, there will be Internet of Things, machines that will use the wireless ambient system, that will populate it with data, that will use it also to feed their own functioning, and that's exactly where we'll be in 7-8 years in the future. So it's not a continuity thing that I'm trying to picture. This is a disruption in terms of how we absolutely need something as good as air. We need it everywhere. We need it in quality, in quantity, and not only the human being will need it, but a lot of the software, smart applications, a lot of the objects and machines will also need it, and that is a different system. So I'm talking about new markets. Internet of Things, machine-to-machine are just at the beginning. Business-critical application, that was pointed out also by Mario. Real-time, public safety, things that need absolutely excellent real-time functioning, which we cannot really do with current systems. And all the quasi-real-time, low-latency, synchronization applications. And all the yet unknown services, because 7-8 years ago, Facebook was not there. Okay, so in the time we take to invent and deploy 5G, there will be new application and new unknown services. So we have to think about technologies, because these new markets we can see, we can guess, just project the past growth, and we can see what's ahead of us. New technology, one is very important, is being named yesterday afternoon and also this morning. Software is getting in the network. We call it from IPization, from IP in LT is 4G is IP everywhere in the mobile network. To ITization, IT everywhere, in the base station, in the mobile, in the routers, virtualized, and as software as possible. So that's one profound transformation that will lead to certain difficulties. I will point out also the challenges of that, but that certainly is a good news, because more software means more flexibility, lower cost. You can cope with new application, you can reprogram your infrastructure, and hopefully accompany the creativity on the application and service space. The second revolution, which is ahead of us in terms of technology, is really the device themselves. Today devices are powerful, lots of memory, lots of processing power, lots of radio capabilities. We do not understand how more powerful will be 7 years from now the devices, how they can become integral part of the networking capabilities, and we have to think deeply how infrastructure and device will have to collaborate to create the Internet as Air, as we discussed. So for Orange, we have in mind 3 different major requirement or areas of need to address in this 5G, which should not be 4G plus 1, which should be different. The first one is really to think hard about energy. We have worked a long history at improving spectral efficiency. How many bits per second per hertz can we transmit? Regardless of how much power you use to do it, we just want to squeeze as much bandwidth in the same spectrum. But if you look at the trends, the share of the cost of energy in creating this Internet as Air is increasing with time. And if we project the trends, if we don't make, by design, an end-to-end energy efficient wireless Internet, then we will suffer from high cost and high dependency on energy. So Air has to be available cheaply. That means we have to squeeze the energy, and it's a major requirement for the horizon we talk about. The second and third factor are more human related. Quality of experience of the users, professional or citizen, by design. What does it mean? Today, with 2G cohabiting with 3G and 4G, you move very easily from 100 megabit per second to 100 kilobit per second, 2 kilometers away, indoor, in the metro. You have a very varying quality of experience, which means you cannot rely on your internet, because sometimes it takes 1 millisecond, sometimes it takes 2 minutes, or even you cannot download this mega piece of software that you want to use. So we as an industry have been used to go faster and faster, bitrate, increase the bitrate all the time. We have to think to provide what we can provide as equally as possible everywhere, anytime, so we have a consistent quality of experience. So it's easier for application developer to have to think, some of my user will be 100 megabit per second, another user will be 100 kilobit per second. How do I cope with that? This is complex. So let's really design and understand what it is a good quality of experience, like the air. Okay, we don't think of the air, which means we have a good quality experience, except when it smells awful. Same thing with the mobile, and it has to be central in the methodology and the research. So no, I'm not in favor of beating speed record is one thing. Everybody can do that. Creating an affordable, excellent, uniform quality of experience, universal quality of experience, that is more difficult engineering challenge, and that's exactly what we need to solve in this time horizon. And third requirement is a bit less glamorous, but as an operator we have to discuss about that, is the total cost of ownership of the network, including its operational and maintenance phase. And I'm adding something because as we think 5G might be really different in its as it was pointed out by Mario, this means we have to dismantle 2G and 3G and 4G to some extent, to transform. And we have to think that because it's a large number of antennas, a large number of fibers and cables that we have to take away and replace by something different in virtualized and software based. So it's probably the first generation by which we have not only to build a new generation, but to think how do we deal with the legacy, because we have to do something with that, and it has to be economical and affordable. And in the operation of 5G, we have to reduce the cost in terms of automation and self-optimization, self-healing. To get to your reliability, to get to your efficiency, we need the software real-time dealing with making the network work in any time at any places. So conclusion. We do not want to think 4G as 5G as 4G plus 1, just more of the same thing. We think energy efficiency, quality of experience, operation and maintenance of this new system, to deal with a new system capable of dealing with very, very different applications, high data rate, broadband, as well as a few bits per second for the machines. We think it is important. We are committed to do research in the framework of 5G PPP to do our share of that thinking. And as I pointed out, the future is not what it used to be, but if we do it right, the future of wireless internet or the ambient internet is what we want it to be. That's it.